Hi, welcome back. We're going to jump back into these Gestalt grouping laws. So after we have distinguished the figure from the ground, what's in front and what's kind of the background and what we're perceiving, we need to organize the information into meaningful form. And when we do this, we use grouping laws. And remember, these grouping laws are called proximity, similarity, closure, and continuity. So let's drill into each of those. The first picture that you see is an example of proximity. So we group nearby figures together. So here you won't say that there's 6 lines. More likely you're going to say that there's 3 maybe pillars in that picture. So the first 2, because they're closer together, we incorporate that into one group or one image because, again, of their proximity. So the second figure that you see, which is the blue circles and triangles, is an example of similarity. So we group similar figures together. And here you're going to see vertical groups, not horizontal groups. So we would look at this picture of similarity and think there's one column of triangles, one column of circles, and another column of triangles. Next, on the bottom left, you're going to see an example of continuity. And what we tend to organize things around in this picture are a continuous line. So we don't look at this picture and say, okay, we have a quarter of a circle that ends, and then there's a horizontal line, and then a half a circle that ends, and then there's a horizontal line. We look at that as one long horizontal line and one long sort of curving continuous pattern over that line. And finally, the figure at the bottom right is an example of connectedness. So we perceive things as a single unit, not as a dot, a little horizontal line, another dot, a space, a dot, a horizontal line, dot, etc. We do not perceive this picture that way. We perceive this picture as 3 barbells, for example. So now I'm going to ask you, what is the grouping law that applies to this picture? Well, if you said the law of similarity, you'd be correct, because we organize this information according to the similar cookies that are in these rows. So, what do you see in this picture? This is an example of the law of closure. We know that that circle, which is the clock face, doesn't actually stop and start again. We know and we perceive that that circle is actually closed. Now look at this one. What is this an example of? So this is the example of continuity, or law of good continuation. Here we perceive smooth continuous patterns, not disconnected ones. And which grouping law applies to this picture? So if you said the law of proximity, that would be correct. Remember, we group nearby figures together. So looking at this picture, we would say there's one family on the right, and on the left is another family or a couple. So there's 2 groups of people in this picture. So now let's look at binocular cues. So binocular cues relate to the concept that images from your 2 eyes differ because they're looking at an object from slightly different angles. So to experience this visual illusion as a result of your binocular clues, try looking at your 2 index fingers when pointing them towards each other, about a ½ inch apart and about 5 inches directly in front of your eyes. What you're going to see, it looks like a finger sausage, or a little piece of your finger with a fingernail in each end shown in the middle of your visual field. So take a moment to try this. All right, so now let's look at this concept of perceptual constancy. When we view something, if we move around, for example, or if the object moves, so this would mean that the conditions of viewing this object or this picture change. The retinal image changes, even if the objects being viewed remain the same. So the important thing to remember here is that our perceptual system is representing a constant environment and accommodates for the change in the retinal image that we experience. So here's what I mean by that. One aspect of this is what we call size constancy. So as the distance between the eye and an object increases, say for example you're looking at a horse that's galloping away from you, we compensate for the size changes related to the distance changes. In other words, the actual image that's cast on your retina gets smaller as the horse moves further away. But we know that that horse is not in reality shrinking, right? That's called constancy. So we perceive objects as having a constant size even while our distance varies. So with size constancy, the depth cues, such as the linear perspective and the texture, help the visual system judge the size accurately. So let's look at a size constancy illusion. Look at the two figures in this picture, the two gorillas. When a figure normally recedes into the distance, it gets smaller. Okay? For example, the visual angle gets smaller. But here, the illusion is that the background figure remains actually the same size as the figure in the front. Okay, you can measure that with your fingers right now. But what's happening in this illusion is that your visual system assumes that since both figures have the same visual angle, but they're at different distances, the one in the background must be larger. Okay, this demonstrates that what you see may not actually be what you perceive. So now, another illusion that your textbook talks about is called the moon illusion. And this is the misperception that the moon is larger when it's on the horizon than when it's up higher in the sky or even directly overhead. So what's going on here is a misapplication of the principle of size constancy. So in reality, the retinal size, so the size that is cast on your retina of the full moon, it's the same in all positions. So the thing to remember about perceptual illusions is the fact that what we see is not merely a simple reflection of the world, but it's also our perceptual interpretation of that sensation. So here's the explanation of the moon illusion. So you can see in reality that the size of the moon is the same. Here's another interesting illusion. Which line looks longer to you? Well, this is an illusion because vertical lines generally look longer than horizontal lines. But in actuality, both of these lines are the exact same size. Let's look at another aspect of constancy, and this is called color constancy. So we perceive familiar objects as having consistent color, even when the changing illumination filters the light reflected by the object. So in reality, you know that these green apples are pretty much a consistent green color all the way around, and they don't really have those splotches of almost white on them and splotches of almost dark green on their sides. So let's look at another illusion, shape constancy. So look at the first two images on the top of that square. So it's hard to tell if the figure on the upper right is actually a trapezoid, or is it this square that you see on the left tilted backwards. So one way to tease through that is to add texture. So if we add those round circles in rows across that square, the texture gradient helps us to see that that figure is actually a square, not a trapezoid. Here's another illusion. Perceptual psychologists have hypothesized that the left horizontal line looks longer. Most of us, when looking at these two lines, would say that left line is longer than the right line, and the reason why is because it looks further away. So perceptual set is a mental predisposition to perceive one thing and not another. Our experiences, our assumptions, and our expectations give us a perceptual set. So here's an example of what I mean by perceptual set. Say that one night you decide to stay home alone, and it's a stormy night, it's windy and it's raining, and you're kind of bored, so you decide to turn on a movie, and the only thing that you can find is a horror movie. So you're watching this terrifying movie, scaring you to death, and all of a sudden you hear some banging on the window, and you jump, and you expect that it's someone trying to break in. And the reason why is because your experience embedded in watching that movie is your perceptual set that you wrap around the sensory input of that banging on your window. So perceptual sets can cause us to misinterpret or misperceive sensation. Here's another interesting application of the concept of perceptual set. People can actually see faces in ambiguous stimuli. So the picture at the bottom left is the face of Jesus in a pierogi or a grilled cheese sandwich. Some people might say that that's also the face of Madonna on a grilled cheese sandwich. So I've posted this link on the week 6 module of D2L. So see if you can identify which Gestalt principle explains the illusion. And on this slide, you're going to see an Octavio Ocampo illusion picture demonstration. This is fascinating as well. And finally, what I would like you to do is take out the Gestalt law, identify the Gestalt law handout that's in this module. And in this handout, you'll see a picture of 1, 2, 3, 4, 5, 6, 7, 8. You'll see approximately 10 figures on a piece of paper. And let's see if you can identify the Gestalt law that's being displayed in the figure. So in this handout, the first thing you're going to see is an example of figure ground. Here it's a picture of an Eskimo or an Indian. The second figure is an example of, again, a changing figure ground. If you look at it one way, you're going to see a hawk. Another way, you're going to see a goose. Now look at figure 4A. This is an example of proximity because you have these circles organized into two groups. So that's proximity. Image 4B is similarity. 4C is similarity. 4D is continuity because you see a spiral, which is one dot on the outside. 4E is an example of closure. If not for closure, it would be a W on top of an M. F is closure as well because you see a triangle. And G and H are examples of the fact that principles get so powerful that they produce illusions.